Hello and welcome to 5-Minute Math. Today we are looking at the 6th grade concept of interpreting numeric data. This is standard 6.13a in the great state of Texas, and we are using item number 2 off the 2021 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we have 160 employees who work for a company, and we might look like we have a bar graph, but it's actually a histogram. And a histogram acts very similar to a bar graph. We have a scale. It's over here on the left. We are going to see these bars right here. Here's the main difference. Take a look at this x-axis across the bottom. The time in months. We just have ranges. We've got buckets, 0 to 5. 6 to 11, and so on. And so instead of just one number being represented by each bar represents a range. That's kind of our big difference between a histogram and a bar graph. And it's useful when you have just too many pieces of data to go across a bar graph. Because once a bar graph gets more than like 6 or 8 bars, it just becomes really hard to read. So this is good for larger data sets. So we need to find not what's false, but what must be true. We need to find one statement here that is true, which means 3 are going to be false. So let's take a look. So before we do that, though, as always, let's go ahead and put some numbers up here. That's what we've been doing with bar graphs ever since we learned about bar graphs in the 1st grade. Always label them. And there's nothing really tricky here. We're not going in between two numbers on our scale to the left. We're just going to go ahead and label all of these all together. And they did already tell us all that together does make 160, so that's helpful. All right, F. There are 5 employees who have been at their current position for 30 to 35 months. So let's take a look at our 30 to 35. That range is 30 to 35, and it looks like, well, yeah, it looks like it goes all the way across to 5. So could it be that simple? Maybe. We'll put a question mark on that. Let's double check. We might be missing something, because that seems like that's a bit obvious. G. There are 6 to 11 employees who have been at their current position for 15 months. Now, take a look at how sneaky this is, because we've got 15. We've got our 6 to 11. So a lot of people are going to be like, yes, but read it slowly. 15 months. Well, if you look at the months down here, this actually is 6 to 11 months. And instead of being 6 to 11 employees, it's 15 employees. They actually flip the numbers. What we need this to say is there are 15 employees that have been on their current position for 6 to 11 months. So they give you the right pieces of data, they just put them in the wrong order. That is extremely tricky. So let's cross that one out. Half of the employees have been at their current position 18 or more. Alright, so I'm going to take there's my 18 right there. So I've got 3 buckets here, 18 to 23, 24 to 29, and 30 to 35. Let's put those together. I've got 45, 20, and 5. Let's see, that's 10. That is 5, 6, 7. So 70 have been at 18 or more. Remember, our total, we could add all of them up, but they already gave us this 160 over here. So half of 160, most of you can do that in your head. That's going to equal 80. So I need 80, not 70. So that is going to be incorrect. And we have another half question down here. Half of the employees have been at their current position 11 or fewer. So I'm looking right here for this next one right here. I'll put a little squiggle there. It's 0 to 5, 6 to 11. There's only 2 buckets. And that's going to be 40 and 15. That is not going to be 80 either. That's only 55, so it's not nearly half. So I guess we were right with our very first response. The answer is F.